Assalamu alaikum, hello and welcome to the Voice of Islam Living History program. My name is Dr. Mohammed Iqbal. I'll be your host for the next hour or so. In today's program, we're going to be looking at mankind's origins and understanding evolution, how our origins are explained by scientists in particular. I'm joined by my panel, Arif, Ahmad and Amjad Hussain again. So, assalamu alaikum to both of you. I just want to set the scene really in relation to mankind's origins and evolution. There are over 7 billion human beings living on today's earth, and we all belong to the one species called Homo sapiens. The name Homo sapiens was coined by Carl Linnaeus, the father of classification, in 1758. The Latin noun homo means human being, while the participle sapiens means discerning or wise, sensible person, which we hopefully are as human beings. As in all species, there is a variation among individual human beings from size and shape to skin, tone and eye color, etc. But we are much more alike than we are different. We are in fact remarkably similar. Our DNA shows that 99.9% of it is alike across the whole of the globe amongst human beings. According to most scientists, we all have roots extending back over 200,000 years or so to the emergence of the first modern humans in Africa, and back more than 6 million years to the evolution of the earliest human species in Africa. This amazing story of adaptation and survival is written in the language of our genes, in every cell of our bodies, in our embryological development in the womb, in the size and structure of our brain, as well as the fossil and behavioral evidence. Amjad, perhaps you could start off by really showing what science has shown in relation to our origins. I'm not going to touch on the religious ideologies, etc., because this is a history program to look at scientific. Just take us through really what science tells us.
Viewed scientifically, we humans are Homo sapiens, as you just alluded to, a culture-bearing, upright walking species that lives on the ground and very likely first involved in Africa about 300,000 years ago. We are now the only living members of what many paleoanthropologists refer to as the human tribe, hominids, but there is abundant fossil evidence to indicate that we were preceded by millions of years by other hominids such as Ardipithecus, Australopithecus and other species of Homo, and that our species also lived for a time contemporaneously with at least one other member of our genus known as the Neanderthals.
And in relation to some of the extinct hominins, how did we come to this sort of thinking, Arif?
Yes, absolutely. So the fact that we and some of the extinct hominins are somehow related, and the fact that we and the apes, both living and extinct, are also somehow related, this is generally accepted by anthropologists and biologists everywhere. However, the exact nature of our evolutionary relationships has been the subject of much debate. I suppose most of our listeners will have heard of Charles Darwin. He was the one that first sort of investigated this, and he wrote 2 books on this subject. The first was The Origin of Species in 1859, and the second one was The Descent of Man in 1871. Now, it's very important to state that Darwin never claimed that some of his Victorian contemporaries said that he never said that man was descended from apes. This is, most modern scientists would say that this is a useless simplification. And just as they would dismiss that there's a popular notion that a certain extinct species is the missing link between the humans and the apes, these are commonly held, I suppose, misconceptions, because it's far more complicated than that.
Amjad, there is a lot of misunderstanding, isn't there, about what Charles Darwin thought and what the neo-Darwinians and people like Richard Dawkins and others talk about, or what do you think?
Well, there is theoretically, however, a common ancestor that existed millions of years ago. This ancestral species does not constitute a missing link along a lineage, but rather a node of divergence into separate lineages. This ancient primate has not been identified and may never be known with certainty because fossil relationships are unclear even within human lineage, which is more recent. In fact, the human family tree may be better described as a family bush within which it is impossible to connect a full chronological series of species leading to Homo sapiens. That's what experts can agree upon.
So, when did humans evolve? Genetic and fossil studies show that primates, which is essentially the monkeys and the apes, had diverged from other mammals around 85 million years ago in the late Cretaceous period, just before the global disaster 65 million years ago that led to the extinction of the dinosaurs. And genetically and from fossil records, we can see this divergence from, how the mammals came about, how the mammals diversified, etc. And then when we look at within the primates areas, we can work out based on the criterion we set. And really we're divided into, we mentioned earlier, the Homo is a genus as we belong to. Well, from genus working upwards, we go to a tribe, then we go to a subfamily, then we go to a family and superfamily. So this way, paleontologists, anthropologists, and others have really looked at the tree that comes down to human beings and that separates us and how we are linked together. And this is the story we're going to follow today with both Arif and Amjad. So, Amjad, because there's a lot of science in this, and I know you have a very strong interest in evolution, etc. Just take us through in relation to some of the early hominids, etc., and where the divergence happened and how it happened from the great apes.
Well, Dr. Mohammed Iqbal said the humans diverged from the chimpanzees about several million years ago. The earliest fossils that belong to the human lineage was found in the Sahel region of Chad, just south of the Great Sahara Desert between 2001 and 2002 at 3 sites. It's named as Sahelanthropus I'll say that again. Chadensis, yeah. Sahelanthropus chadensis. In translation, it simply means human from the Sahel of Chad, and is the likely ancestor of a hominoid known as Ororantunosis. And which basically in the Kenyan language means the original man. It is a species of hominy that lived about 6 million years ago and is now regarded as the earliest possible known human ancestor, if you can call it that way. This was followed by Ardipithecus that lived about 5.5 to 4.4 million years ago, with two species known as Ardipithecus cadaba and Ardipithecus remedus, both discovered and named by the Ethiopian paleoanthropologist Johannes Haile Selassie in the Afar region of Ethiopia in 1997.
So these were some of the earliest findings, and they're much more recent, because I remember growing up when I was going to my schooling and university with Richard Leakey and the Making of Mankind series and all those, where they talked about obviously the Homo genus and then the Australopithecus, which we'll come to as well. But up till now, they found even earlier links, Arif. So perhaps you could take us through the next bits, because we know how these early hominids go back as far as nearly 7 million years ago, but we're then getting closer towards the Homo. Take us through the late Miocene.
Yes. So the late Miocene age is about 11 million years ago to about 5 million years ago. And in many regions, they were inhabited by ape-like primates. They were evergreen, broadleaf forests. These begin to be replaced by open woodlands, shrublands, grasslands, and mosaic habitats. And sometimes they were denser canopied forests, which had lakes and rivers and streams. Now, these diverse environments, they stimulated adaptations. And obviously one of the most important one is locomotion, moving, of many types of animals, including primates. So there was a lot of variety in a greater number of animals such as antelopes, pigs, monkeys, giraffes, elephants, and other animals for the adventurous hominids to scavenge and perhaps kill. But also animals such as cats, dogs, hyenas, they also flourished in these new environments. So they not only provided meat for scavenging hominins, but they would also compete with and possibly even prey upon them. Whatever the case, our ancestors were not, as many people might think, heavily carnivorous. Instead, they relied on a diet of tough, abrasive vegetation, which included seeds, stems, nuts, fruits, and leaves. And this is proven by the primate remains, which have large premolar and molar teeth with thick enamel. The premolar and molar teeth, they're the hind teeth, the teeth at the behind. And this shows that, predominantly they were not necessarily meat eating, more vegetation eating. So the development of bipedalism, which is walking on two legs, this enabled hominins to establish new niches in forests, closed woodlands and open woodlands, and even more open areas over a span of at least 4.5 million years ago. Terrestrial bipedalism, that's the ability and necessity of walking only on the upper limbs. This is a defining trait required for classification in the human tribe hominid, and we're going to talk about that, I'm sure.
I think with Amjad, let's build on this, because this was a crucial step from the apes obviously using trees, living amongst trees and getting on, and now the vast savanna with the change with the grasslands. You couldn't swing from tree to tree, you had to walk long distances, and so bipedalism may well have been the defining feature that took us along a different path. Just take us through the importance of bipedalism. It's not straightforward, suddenly you wake up and you're walking on two legs. Go on, Amjad.
No, absolutely. Bipedalism is not just unique to humans, though our particular form of it is. Whereas most other mammalian bipeds hop or waddle, we stride. Homo sapien is the only mammal that is adapted exclusively to bipedal striding. Unlike most other mammalian orders, the primate have hind limb dominated locomotion. Accordingly, human bipedalism is a natural development from the basic arboreal primate body plan, in which the hind limbs are used to move about and sitting upright is common during feeding and resting. Fortunately for paleoanthropologists, some bones...
These are people who look at fossils and whatever, just for the average listener. Yeah, go on, carry on.
Paleoanthropology is the study of the evolution of mankind, and they also look at the fossil records through fossils and other means, yes.
Okay,
so when these scientists, they look at some bones, and the bones showed dramatic signs of how a given hominy carried itself, and the adaptation to obligate terrestrial bipedalism led to notable anatomic differences between hominids and great apes. These differences are readily identified in fossils, particularly those of the pelvis and lower limbs.
I think when you look at actually movements of locomotion and muscle and structure between the apes and human, it's quite striking how this difference occurred, which gave the Homo the divergence advantage, etc. Or in some ways it may have been an advantage as well. And then when you look at some of the fossil records, you can see the way the feet start changing from a grasping type of foot to a walking, which we'll come to. Arif, the group that started this walking process more, we talked about Ardipithecus ramidus and Aurorin Turgigenesis as well. Just take us through some of that development.
Yeah, so from the remains found in Kenya from the 6 million old
these are the femoral, the
legs, basically the bones.
Yeah.
So it was found that both of these were basically bipedal, and the evidence comes from looking at the foramen magnum. That's basically the hole in the skull through which the spinal cord enters. And you might wonder, how can you tell from there? In Ardipithecus, this opening is similar to the ones in ours, which suggests that which is basically centrally under the skull. And that suggests that basically they were bipedal. So a rear-facing foramen magnum indicates a stooped posture. So just the actual position of this, you can tell the posture of the animal. So a rear-facing foramen magnum indicates a stooped posture, whereas a downward-facing hold positions, the skull atop or the spinal column, suggests bipedalism. So other characteristics which are indicative of bipedalism are an increased tarsal region, which is in each foot, and a pelvic structure with muscle to bone attachment sites comparable to latter bipedal humans. So you can see that a lot can be determined from the fragmentary remains of legs and both pelvis as well.
So you move from the hominids who are basically using both trees and trying to walk on bipedalism to a more established walker, which are the Australopithecines. Australopithecus was really the big breakthrough. Lucy, I remember in the 70s, was the great find. So just take us through, in particular in relation to the Australopithecines, because a number of them have been found now throughout Africa, South Africa, etc. So just take us through those, the genus.
Well, the genus Australopithecus evolved in eastern Africa around 4 million years ago before spreading throughout the continent and eventually becoming extinct 2 million years ago. During this time period, various forms of Australopithecus existed, including Australopithecus anonymous's, africanosis, and Australopithecus Cedabia and Australopithecus africanus. There is still some debate among academics whether certain African hominid species of this time, such as Australopithecus robustus and Australopithecus biocesis, constitute members of the same genesis. If so, they would be considered to be Australopithecus robustus Australopithecus, while the other would be considered Australopithecus.
I mean, the numbers just massively increased in terms of the finds, isn't it? Because I remember it was quite scarce early on in the 70s when there were all these programs about making of mankind, evolution or development, and the names, I was quite amazed at such a variety of finds they have. But clearly, one of the things you see in the Australopithecines now is their feet are much more adapted to walking, rather than having this grasping look as well. And that was a major differentiator, I suppose, in the line that human development took. And you mentioned a number of different lines. And this, of course, then takes us now to the more important line in differentiation, the Homo genus. And that's where we're going to spend a lot more time. So by 3.5 million years ago, at least, one hominin species, Australopithecus afarensis, was an adapt walker. That's absolutely clear. And then we start seeing the Homo genus. So I think probably we'll get back to Amjad to take us through that, because it's such an important transition, isn't it?
Well, the earliest documented representatives of the genus Homo is Homo habilis, which evolved around 2.8 million years ago, and arguably the earliest species of which is there's positive evidence for the use of stone tools. The brain of these early hominids were about the same size as that of chimpanzee, although it had been suggested that this was the time when the Homo brain, a significant change in the wiring of the frontal cortex possibly occurred.
Yes, so just building upon that, during the next million years, a process of rapid encephalization occurred. And
this is a process just the brain in terms of the size and complexity. And I think you'll have seen the different visuals of the different hominids, etc., and how the cranial capacity increased massively. So that's quite clear and evident from lots of different, people who do research into this. But carry on.
And so what that basically meant is you'll have seen these different skulls and the shapes. And what this enabled was the cranial capacity, that's the brain capacity, that doubled to 850 centimeters squared. And
Cube,
my apologies, cube.
Capacity,
and such an increase in this human brain size, it's the equivalent to each generation having 125,000 more neurons, basic brain cells, more than their parents. And it's also believed that Homo erectus and Homo ergaster were the first to use fire and complex tools, and they were the first of the hominin line to leave Africa, spreading throughout Africa, Asia, and Europe between about 1.3 to 1.8 million years ago.
So this is really quite an important stage. And you mentioned Homo habilis, because I remember over the last 20-odd years, there's been a lot of dispute. Is it really a Homo? Was it a Australopithecine? Because it was much smaller. It was almost like you've seen Lord of the Rings with the small guys. I can't remember.
Hobbits, yeah.
The hobbits with whereas the Homo erectus and Agaster and later on Homo sapiens were much taller. So now you've got really the important development of Homo erectus walking perfectly straight and in line. But there is a little bit we need to do in relation to the different types of erectus, because Homo Augusta, in the old days, we always knew that it was just Homo erectus, but now they're saying that there is an African version which is erectus. Amjad, maybe you could take us through that.
Archaeologically, lithic technology includes a broad array of techniques used to produce usable tools from various types of stones. The earliest stone tools were recovered from modern Ethiopia and were dated to between 2 million to 3 million years old. So that really explains the evolution of the cranium size, as my colleague alluded to earlier. The archaeological record of lithic technology...
They're much more linked to the Homo erectus and Agesta, the stone, the tool usage, etc. So yeah, now take us through the terms so that we understand. Yeah, go on.
Well, basically the paleoanthropologists divide this three major time periods: the Paleolithic, that's the Old Stone Age, about 3.3 million years ago; and Mesolithic, which is the Middle Stone Age, that's between 20 to 8,000 years ago; and Neolithic, that's the New Stone Age, which is 10,000 to about 450 BC, basically. Sorry, 4.5 BCE. So according to recent African origin of modern human theory, modern humans evolved in Africa, possibly from Homo heidelbergensis.
This is related again. Heidelberg was the place where they found them and they gave that name. But go on, carry on. Yeah, just for listeners, go on.
And Homo rhodensis and Homo ancestor and antecessor, and basically migrated out of the continent some 50,000 to 100,000 years ago, gradually replacing local populations of Homo erectus, and there will be various homos like Homo Neanderthal. So archaic human Homo sapiens, the forerunners of anatomically modern humans, evolved in the Middle Paleolithic between 400,000 to 250,000 years ago. Recent DNA evidence suggests that several Neanderthal origin genes are present among all non-African populations, and Neanderthals and other hominids such as Denisovans may have contributed.
This is around the Siberian area, the cave Deniso. So they found basically another type linked to the Neanderthals. Sorry, carry on.
So they possibly contributed up to 6% of their genome to present-day humans, suggestive of limited interbreeding between these species. So the transition to behavioral modernity with the development of symbolic culture, language, and specialized stone technology happened around 50,000 years ago, according to some anthropologists. All the other points to evidence that suggests that a gradual change in behavior took place over a longer period of time.
Well, this is fascinating because in second part of this program, we're going to talk now in a lot more detail about these Homo species, because each one of them has some interesting details in terms of our evolution. But one thing that seems to be quite clear from the fossil records in terms of paleontology and paleoanthropology studies, as well as DNA genetic studies, is that we can trace back using both our origins to over 7 million years ago, with a number of different hominids that came along, etc. And more than likely, modern human beings, Homo sapiens, really came out of Africa. But prior to them, there had been other Homo species as well. And we're going to go into a lot more detail for that. Well, I hope that wasn't too much for listeners for the first part, because we're going to take a break now and come back and look at each of these Homo species in a lot more detail and discuss and debate them. You are listening to the Voice of Islam Living History program. Today we've been talking about the origins of mankind and looking at some of the evolutionary evidence, fossil evidence that is presented to support this theory. if you want to listen to some of our other Living History programs, please go to our website www.voiceofislam.co.uk and look under the program section of Living History. You will see over 25 recorded programs on a variety of subjects, a detailed history of Islam, its origins and the different empires that have come up to the Mughal Empire, the Ottoman Empire, etc. We've also looked at some of the Western origins of the civilization that we live in currently, and some of the ancient civilizations of antiquity. And we have also looked at some really interesting topics like what the different ideas and theories have been in terms of origins of the universe, how different thinkers have tackled this over the many hundreds and thousands of years. Looking at the Big Bang and the infinite universe concept, etc., and what the different religions say about that, in particular Islam, and we related it to some of the teachings in the Holy Quran. We have also looked at the origins of language, and this program will quite nicely go to link up with that in terms of our evolutionary development and migration out of Africa. But that program in itself is a very interesting one. We would love to have your feedback on any of the programs that you've listened to. Our hashtag, Arif, you're always better than me at this one.
On Twitter, we're at VI Living History. Please give us your comments and your feedback. We really appreciate it. Give us your ideas for future programs. We're very gratified by all of the great feedback that we get from our listeners, and long may it continue.
And in due course, we are hoping to develop our website. The SoundCloud is excellent if you just want to look at it, explore it, and give us some feedback. But in due course, we will put on our website these programs in different sections. And as Arif said, we look forward to your feedback. So welcome back to the second program on the making of mankind, or the origins of mankind, as we said at the start of the program. So in the first part, we looked at how the divergence of the human being started around 7 million years ago from the missing link, as some would have put it, but between primates and the Homo group. And we went through the different hominids that came across from Ardipithecus, the Australopithecus. I'm not going to go into all the different names, but that was a grouping. And then we came to the Homo genus, and we briefly looked at some of the key features. But I want to go into the details now for each of the Homo hominids. Let's start off with the Homo habilis, because this was the first one. The term, I think it means handyman, doesn't it, Amjad? Just take us through Homo habilis and its importance.
Quite right, Dr. Iqbal. So the Homo habilis, one of the first known hominids, nicknamed handyman by one of his discoverers, Louis Leakey, due to his association with stone tools. Homo habilis lived from about 2.8 to 1.4 million years ago. The species evolved in South and East Africa around 2.5 to 2 million years ago. It diverged from the Australopithecines, basically. So Homo habilis had smaller molars, larger brain than Australopithecines, and made tools from stones and perhaps animal bones too. Sharp-edged stones, even small flakes, would be a boon to early homini who learned how to select and make them for cutting hides, meat, sticks, and other plant material. Stones also would assist in pounding open hard fruit shells, nuts, bones, marrow, and skulls for brains. They would also have been a span when early hominids used naturally occurring stones and other objects as tools and weapons, much as some wild chimpanzees do to this day. The use of tools have been interpreted as a sign of intelligence, and it has been theorized that tools used may have stimulated certain aspects of human evolution, especially the continued expansion of the human brain. Many species make and use tools, but it is human genius that dominates the area of making and using more complex tools.
A lot of these tools were found in Africa, weren't they? And there's a particular region in Kenya, I think.
Yeah, the oldest known tools were flakes from West Turkana in Kenya, which dates to 3.3 million years ago, and the oldest stone tools are from Gona, Ethiopia, and are considered the beginning of the old Oldhovian technology. These tools date to about 2.6 million years ago. A Homo fossil was found near some old woven tools, and its age was noted to approximately 2.3 million years old, suggesting that maybe the Homo sapiens did indeed create and use these tools, and it is possible, but does not yet represent solid evidence.
So this became an important feature because the early hominids were basically scavenging, with other carnivores that may have hunted and left things, and they were eating. But now they were able to make tools to hunt their own prey in some ways, and make use of the hides, etc., by cutting away as well. There are a number of in-between hominids, because I want to move on to Homo erectus and Homo ergaster, but just to say that there are a number that have been described from 1.9 to 1.6 million years ago, and these are well documented for those who want to sort of research into it. But let's go to Homo erectus, Arif. This is a hominid that lived about 1.8 to about 70,000 years ago, and originally African origins, everybody thought, but they seem to be much more widespread. Just take us through really.
Yes. So the early phase of Homo erectus from 1.8 to 1.25 million years ago, this is considered to be, by some, to be a separate species. Homo ergaster, or as Homo erectus ergaster, subspecies of Homo erectus. Many paleontologists now use the term Homo ergaster for non-Asian forms of this group, and they use Homo erectus only for those fossils that are found in Asia and meet certain skeletal and dental requirements, which differ slightly from Homo ergaster. Around 1.5 to 1 million years ago, some of the Homo habilis, they were thought to have evolved human brains and to have made more elaborate stone tools. And this is very important because these differences...
So when you say human, larger brains, really, in terms of complexity and size as well.
Absolutely. And as I said, these differences are enough for some anthropologists to classify them as a new species, actually. And they actually call them Homo erectus. So the evolution of locking knees and the movement of the foramen and magnum are thought to be the likely drivers of the larger population changes. And these species are also believed to have possibly used fire to cook meat. It's believed that this Homo seems to have been ground-dwelling, living on the ground, reduced intestinal length, and smaller teeth, and they swelled their brains to our current, fuel-inefficient size, suggesting that the control of fire and releasing increased nutritional value through cooking was a key adaptation that separated Homo from tree-sleeping Australopithecines.
So really, big development in terms of bipedalism, walking, using tools, and perhaps an accidental discovery of fire, but not running from that fire and using it to their advantage, and then cooking the meat, and maybe that also contributed to additional nutrients and the brain size growth, and you see this really exponential growth in brain from Homo habilis onwards. The other interesting thing that's come is how widespread the Homo erectus and ergaster were as well across Africa as well as Asia. So they were probably the first hominids to get out of Africa and populate the world. So overall, they were differentiated in terms of a larger brain, dexterous fingers that could use tools a lot more, and having long legs. They'd need them to walk out of Africa. And then the use of fire. There is another hominid group, Homo heidelbergensis, isn't there? Because some think that the Homo sapiens may have evolved from Homo erectus, some believe Homo heidelbergensis. Amjad, do you want to just take us through this particular hominid and their importance?
Well, basically, the Homo heidelbergensis, or if you can call it Heidelberg man, lived around.
Yeah, that's the best way of describing it.
Lived from 800,000 to approximately 300,000 years ago. And I think paleoanthropologists reckon it's a hybrid species, really, a hybrid hominid between Homo erectus and Homo neanderthalis. With a typical cranium volume of approximately 1,250 centimeter cubes. The anatomy of, that's basically the anatomy of this hominid, is clearly more primitive than of the Neanderthal, but harmoniously.
Because the Neanderthal was more European, and these guys seem to be both around the European area as well as Africa, widely across Africa. In fact, Ethiopia, Namibia, Southern Africa, etc., etc. So, yeah, go on.
But possibly England, France, Germany, Greece, basically Europe. It's exact relationship both to the early hominid ancestor and basically Homo augusta, and to the later species Neanderthals and modern humans is unclear. In general, the finding shows basically a continuation of evolutionary trends, along with changes in the robustness of cranial and dental features. A remarkable increase in brain size from Homo erectus towards Homo heidelbergensis is notable. The modern humans have been proposed to derive from Homo heidelbergensis via Homo rhodesiensis, if I said that correctly, present in East and North Africa from 400,000 years ago. Several attributes of human species appears first in Homo heidelbergensis, according to Smithsonian National Museum of Natural History. It was the first species of the genus Homo to build permanent shelters. Furthermore, Homo heidelbergensis was the first Homo with the body shape that enabled it to withstand colder temperatures, paving the way for its successors to adapt to even colder landscapes. So basically, Homo heidelbergensis could conserve more body heat to endure harsher climates because his body was comparatively wide in relation to his height.
In a previous program, we talked about the development of language in early humans and also the divergence of different languages, etc. And interestingly, in terms of the development of language, Stephen Mithen, an important scientist in this area, believes that Homo heidelbergensis, like its descendant, the Neanderthals, acquired a pre-linguistic system of communication. Interesting, isn't it? Homo heidelbergensis is thought to have been the first ancestor of modern humans, not to have air sacs, which are laryngeal, diverticular, involved in vocalization. I know it's a mouthful of science, but basically this is an important evolutionary development in terms of language and how we get the different chords to work. And the loss of air sacs may have contributed, he says, to humans' ability to develop vocal language. Ancestors such as Australopithecines did have air sacs, as do other great apes. And furthermore, there is evidence that Homo heidelbergensis was right-handed. How they worked that out, God knows. Handedness is associated with the development of language among hominins. Considering this evidence, scientists have hypothesized about the speaking capabilities of the species. A recent study that occurred compared the speech frequency of humans and chimpanzees and reported that Homo heidelbergensis speech abilities more closely resembled those of modern-day humans. So that's why they're saying this group is a very, very important one for us to know and to understand. And it does seem that, these chaps were living fairly close to each other when you start looking at the timescales there that we're giving, that when Homo erectus and Augusta and heidelbergensis and Neanderthals as well, they were sort of exchanging glances in some ways. So let's talk about this important group now, the Neanderthals, because a lot of information has been available. In fact, they were probably one of the earliest finds for fossil records in telling us about evolution. So, Arif, just tell us about Neanderthals.
Yes, I think a lot of our listeners will have heard of Neanderthals.
Yep.
It usually uses the term of abuse.
It's got good promotion as Neanderthals.
But essentially, they lived in Europe and Asia from around 400,000 years ago to about 28,000 years ago.
Which is not that long.
Not
ago,
that long in the history of
yeah,
mankind.
yeah.
There are a number of clear anatomical differences between Neanderthals and modern humans, and many of these relate to the superior adaptation to cold environments which the Neanderthal populations had. So they had significantly larger brains, but they've also the research has also shown that they had important differences in their brain architecture to modern humans. And as an example, if you look at the eye socket, the larger size in the Neanderthal suggests that they had better vision, basically, than modern humans. And the reason why they would have needed this superior vision is that in glacial Europe at that time, there was much inferior light conditions, so they would have needed stronger eyes to be able to see in those conditions. It also seems that they had a higher body mass and a correspondingly large brain mass, which was required for body care and for body control as well.
Yeah, interestingly, as I said earlier, the fossil records now have been supported by DNA sequencing and
particularly the mitochondrial
DNA. Absolutely, yeah. And this is an organelle within the cell, the mitochondria, and it has its own DNA, and that sort of flows from female, and you can trace back really a lot of things. And well, what's being now said is that Neanderthals and Homo sapiens, and the two were separate species that shared a common ancestor about 660,000 years ago. However, sequencing of the Neanderthal genome in 2010 indicated that Neanderthals did indeed interbreed with anatomically get a mouthful. Anatomically modern humans around 45,000 to 80,000 years ago, because before it was thought that they all lived in their separate ways, but clearly the DNA is showing that there was intermingling as well. All modern non-African humans have about 1% to 4%, according to this research, or according to more recent data, about 1.5% to 2.6% of their DNA derived from Neanderthal DNA. So that's, modern human beings. It's really interesting finding. Arif, take us through also the sort of the Denisovans, which were discovered around this cave called Denisova Cave in the Altai Mountain, Siberia.
In Siberia. So yes, in 2008, Dr. Saab, there were some archaeologists working in Siberia, and they uncovered a bone fragment, which was from the finger of a Denisovan, and that was estimated to have lived about 40,000 years ago. The full genome sequence suggested that the Denisovans belonged to the same lineage as the Neanderthals, and that basically the two diverged shortly after their line split from the lineage that gave rise to modern humans. Modern humans are known to have overlapped with Neanderthals in Europe and the Near East for possibly more than 40,000 years. And this discovery raises a possibility that Neanderthals, Denisovans, and modern humans may have all coexisted and interbred as well.
This is really fascinating research. You'll, like me, I'm sure will have followed from the 70s the developments, and a lot of it, and early on, was based on fossil evidence and other things. But the DNA work has been really quite amazing to really add to
it's remarkable.
our
I think
knowledge
it's really basically taken the whole studies of human genome and human species to a different level altogether. Now we have genetics to underpin it as well.
Absolutely. So now I'm going to move to the most important Homo species, and that's Homo sapiens. That's us. The earliest fossil evidence of early Homo sapiens appears in Africa around 300,000 years ago, as we said earlier on. And the divergence of the lineage leading to Homo sapiens out of ancestral Homo erectus or an intermediate species, as we said, such as Homo heidelbergensis or Homo antecessor, is estimated to have occurred in Africa roughly about 500,000 years ago, 500,000 years ago. So Amjad, just take us through some of the important developments that we've learnt about Homo sapiens and their divergence and diversification.
Absolutely. Basically, the time period they mentioned, Arif, is absolutely crucial. This 500,000 years ago, 500,000, 400, between, so basically 400,000 years ago, and the second interglacial period around 250,000 years ago. The trend in intracranial volume expansion and the elaboration of stone tool technologies developed, providing evidence for transition from Homo erectus to Homo sapiens. The direct evidence suggests that there was a migration of Homo erectus out of Africa, and then a further speciation of Homo sapiens from Homo erectus in Africa. A subsequent migration both within and out of Africa eventually replaced the earlier dispersed Homo erectus. This migration and the origin theory is usually referred to as the recent single origin hypothesis, or colloquially known as out of Africa theory of Homo sapiens. So basically, Homo sapiens interbred with archaic humans both in Africa and in Eurasia. In Eurasia, notably with Neanderthals and Denisovans, as my colleague mentioned earlier.
This is where the story really becomes quite fascinating. So the dispersal of Homo sapiens begins soon after its emergence. And there is indirect evidence for Homo sapiens' presence in West Asia around 270,000 years ago. Interestingly, in September 2019, scientists proposed that the earliest Homo sapiens and last common human ancestor to modern humans arose between 350,000 and 260,000 years ago through a merging of populations in East and South Africa. Just a little explanation on some of the terms we're going to use. When we talk about the term anatomically modern humans, depending on context, but it distinguishes anatomically modern Homo sapiens from archaic humans such as Neanderthals and middle and lower Paleolithic hominins, with transitional features intermediate between Homo erectus, Neanderthals, and early anatomically modern humans. It's just that now, because we have got so much specialized knowledge to differentiate, whereas before it was a straight jump from erectus to Homo sapiens, etc. So I just wanted to explain that to listeners. Just Arif, take us through now this intermingling of these different species, because especially across Eurasia, a lot of this was happening. You'd already had these different groups of hominids we mentioned?
Yes, absolutely. So in Eurasia, interbreeding between the Neanderthals and the Denisovans with modern humans, this took place several times. And this is believed to have happened between 47 to 65,000 years ago with Neanderthals, and about 44,000 to 54,000 years ago with Denisovans. Neanderthal DNA, the derived DNA, was found in the genome of all contemporary populations. It accounted for about 1% to 4% of modern genomes for people outside sub-Saharan Africa. And although it varies, and either none or possibly, according to some evidence, 0.3% for those in Africa. Denisovan-derived ancestry is absent from modern populations in Western Eurasia and Africa. The highest rates of Denisovan admixture has been found in Oceanic and certain Southeast Asian populations.
So this is going towards Southeast Asia, I think Asia and Pacific.
The Pacific area. And in these populations, it's an estimated 4 to 6% of the genome, with modern Malaysians being derived from Denisovans, for example.
Well, that's interesting, Amjad, isn't it? Because when you consider that these are sea roots, So, whereas in a lot of Eurasia, there was a lot of intermingling and mixing, and with genetics, the gene pool just gets more and more. Whereas in Africa, you'd had the sort of original hominids and then evolving in their own ways.
Absolutely.
And then these cut-off islands, once they'd had the intermixing with the Denisovans, they kept their
gene pool intact.
Yeah. It's interesting. So sorry, Arif, carry on. Yeah.
No, it's fine. And then, Denisovan-derived ancestry has been found in very low trace amounts in mainland Asia, and a relative elevated Denisovan ancestry in South Asian populations. Regarding Neanderthal admixture, it's found in all non-African groups, and according to some research, to a much lesser degree in African groups. It is highest in the East Asians, intermediate in Europeans, and lower in Southeast Asians. One thing which I found very interesting is that recent evidence suggests that the Australian Aboriginal population separated from the African population 75,000 years ago and made a sea journey of up to 160 kilometers about 60,000 years ago. So you wouldn't necessarily put Aborigines and Africans together, but it's remarkable.
It's always
to think.
Fascinated me, this both in looks
Yes.
and culture and whatever. And then, of course, we know from geological terms with the glaciations and whatever, the oceans allowed movement at different times, and maybe the Australians had this initial intermingling. And then they were cut off, whereas across Asia and Africa, there was still a lot of interbreeding and intermingling. So fascinating.
There is the Aboriginal Australian population, and also the basically these islands that exist in the Pacific.
And all the
there is a genetic gene pool. There is a linkage there.
So we basically see this out of Africa theory being established now more and more across the scientific community. Until about 50,000 to maybe 40,000 years ago, the use of stone tools seems to have progressed stepwise. Each phase with Homo habilis, Homo ergaster and Neanderthals starting at a higher level than the previous one. But after each phase started, further development was slow. They seem to have got and set in their own ways. And currently, paleoanthropologists are debating whether these Homo species possess some or many of the cultural and behavioral traits associated with modern humans, such as language, complex symbolic thinking, technological creativity. It seems that they were culturally conservative, maintaining simple technologies and forging patterns over very long periods. Amjad, I think we're getting to this interesting phase now where creativity in Homo sapiens is really taking off. So just take us through from 50,000 years ago, and I think we'll have to round off pretty soon. Yeah,
absolutely. Probably one of the most important period in our evolution is basically, as you mentioned, occurred around 50,000 years ago, where modern human culture started to evolve more rapidly. The transition to behavior modernity has been characterized by some as the Great Leap Forward, or commonly known as the, in scientific terminology, Upper Paleolithic Revolution, due to the sudden appearance of distinct signs of modern behavior and big game hunting in the archaeological record. And modern humans started burying their dead, and for instance, using animal hides to make clothing, hunting with ever more sophisticated techniques such as using trapping pits or driving animals off the cliff, and engaging in creative arts such as cave painting. As human culture advanced, different populations of humans introduced novelty to existing technologies. Artifacts such as fish hooks, buttons and bones needles show signs of variation among different populations of humans. So basically something had been happening or seen in the human cultures that was never seen before 50,000.
So really a fascinating story with a variety of different hominids coming out of Africa, and some of them populating in phases, but Homo sapiens ultimately 250 to 300,000 years ago coming and really taking over. And they had a much better brain, adaptable body structure, etc., were able to work better in tribes and you really populate the earth. And there was some intermingling, it's quite clear early early on as well. And early humans tended to be hunter-gatherers, like many of the nomadic tribes tended to be as well. But clearly, they settled down, some of them around the city, the rivers, and creating the city-states. Some of them remained nomadic, but overall, they learnt, and where the Fertile Crescent around the Middle East was probably the most important areas where there was this mingling that was going
Basically,
on.
yeah, modern-day Iraq and Syria is one of the cradles of human civilization. Well, the modern human civilization as we know it.
Yeah. I mean, I think some of these we've touched in our previous programs. And basically, the springboard for humanity and human development have been set. But I think it's been a fascinating story, and I hope our listeners found it interesting as well. The human story goes on. Now we're looking at going to the moon and maybe, who knows, Mars and outside. Only God knows what our final destiny is, but the story of mankind on earth has been really, really interesting. I want to thank Amjad and Arif for their wonderful contributions. We've got lots of other programs planned as well, but we want to give you a variety. So until next time, Assalamu alaikum.